This first example using the law of cosines is going to focus on side, angle, side. Now remember, side, angle, side is not the same that you learn in geometry where you use it for congruence or similarity proofs. It's just the given information. You're given a side, an angle, and a side where the angle is in between the two sides. That's what that means. So when we look at the information, we're given that much, and we need to label it a little bit more. They gave us the labeling of ABC, just like we would in geometry class, but we need to remember that a side is called little c, and so we just go across from here and call this little c. We go across from B and call this little b, and we go across from A and call this little a. And that's probably the biggest change from geometry to trigonometry, because in geometry you'd have to call this side BC or something, but in trigonometry you just call it lower versus uppercase, and you can see I've set it up here. So when you see this kind of arrangement, we're solving for all sides and all angles in the triangle. So how do we use the law of cosines for this, and why are we using the law of cosines? We're using the law of cosines because it's not a right angle, and we're using the law of cosines because I have side, angle, side with the angle contained. So when I look at it, the first thing that I want to find is the side, because I need to find all sides to find an angle. So I actually need to find this first. So I would do c squared is equal to a squared plus b squared minus 2ab times cosine of the angle that is directly across from the side you're trying to find. And if I want to find the angle, it doesn't really matter which one you start with. They gave us c, we might as well find a. That would be a squared minus b squared minus c squared divided by negative 2 bc. And so those two equations, when you look at them, again, c squared, if I want to find the side, I need a squared plus b squared minus twice their product, and then cosine of the angle directly across from the side that I'm looking for. Keep in mind, when you use this formula, this and this should match always. All right, to do the angle, I'm going to do a squared minus b squared minus c squared. Of course, we have to find c to be able to do this, and then we divide by minus 2bc. So in this one, these two, this one and then the leading one always match. All right, so next thing you're going to do is you're going to put in all the information, and as you can see, just to save time in this video, I've kind of pre-selected that information. A is 21, B is 15, and then cosine of 105. And then over here, I went ahead and put in what A and B were, and I don't know C. So I just wrote C. And this is actually extremely useful. You'll see in the calculator, you don't actually have to input C with, numbers. You can use the calculator to help you. I mean, you have to know what it is, but it will help you do that. And I'll show you that to you in just a second. So before we type anything in the calculator, we have to realize that these are not solved. So for instance, if I type this in, I'm going to get a number that is squared. So I actually need to type in this, I need to take the square root of this whole thing. And the reason we don't do that in the formula is it sure would be hard to go from a square root to this thing. So we go ahead and put the square root in so that what we're going to get is C. And over here, you might notice, oh, well, I don't have angle A. I need to inverse cosine or arc cosine this to cancel this. And that's what you actually type into the calculator. So it's really important, if you haven't watched the video on right angle trig, it's very important to watch that video and understand why this has to be arc cosine because I'm finding an angle. And this one's really, just algebra. I got to solve for C. But the video is explaining why, sides are lowercase and why angles are uppercase and why I have to use arc functions in order to find angles. Very important video to watch before you've seen this one. So what I'm going to do now is I'm going to show you again. So that one comes out looking like that. A is equal to the arc cosine of this information, including C. And then I'm going to show you what happens in the calculator. You literally should type this whole thing into the calculator and then take the square root. Or if you're really good with calculator, just square root the whole thing and just realize the reason I did it like this is I want you to realize that this number makes no sense with respect to the other pieces of 21 and 15. The biggest mistake students make, believe it or not, is they think the answer is 829. They don't realize they need to take the square root. So once you take the square root, you get that the side you're missing is 28.793. And you can immediately store that. And so the way I did this on the calculator, there's a button for store. On the TI, it actually says STO, and it's on the left side of the calculator. And on the Casio, it's a little arrow. And the reason that's important is once I store that, I can then directly use it over here. Okay, so I can directly use that in my calculations in my calculator here. So you can see I just kind of kept going. So I stored that as C, and then I typed in that information, and then I inverse cosigned it. Now, when I say answer, if you inverse cosine on the TI, it will directly put this in there, so there's no reason to do it. But you could have typed it here, which would have been maybe just a little challenging. And please also notice that I had put the TI into fraction mode, which is alpha F1, to do this. Now, regardless, calculators in general are a little more frustrating than using a program like Desmos. So notice how nice and fluid it looks on Desmos. So on Desmos, I was easily able to type the entire thing in with the square root. Notice I got the exact same answer. I was then able to just say C equals that, and you can literally just copy and paste that in there. You don't have to find a special button. And then I was able to then type in inverse cosine of all of this information. I did have to type that in, of course, and it just goes into fraction mode easier. And I can then use C as long as I had defined that as C. I can just type C in, and I can use it here, and it will give me, as you can see, the exact same answer. So that's very convenient, and it's very fluid. And remember, on the SOL in the state of Virginia, you can use Desmos, and I would recommend it highly. It just really helps you see what you're doing. The only thing that students do in this chapter is they make little mistakes. They get things out of order, and you can clearly see it's 2115, 2115, 105. You can see how clearly it looks like what we wrote down. Again, the other thing people make the mistake of is they forget to take the square root, and they forget to use the arc cosine here. They say cosine on accident. They also leave it in radian mode. Look how everything's nutty in radian mode. You got to put it in degree mode. And also, if you don't want to type in cosine inverse, you can always type in arc cosine. Just make sure you put 2 C's in it. And the cool thing about Desmos is, watch, if you mess up, it'll put a little thing here, and it'll say, oh, I don't know what you're talking about. You need to include some extra letters. Oh, I made a typo. Boom. And it gives me the answer. All right, so now we're going to take all this information and we're going to go organize it. So when organizing this information, you come back up to the top, and you always write down what you're given. You could have done this first, but I wanted to focus on the equations. So I was given C is 105 degrees. I was given that A was 21 centimeters and B was 15 centimeters. Make sure you include your units. And then this one I got from the blue work here for the Law of Sines for sides. I got it right there, 28.793. And then the 44.78 degrees I got from working through the Law of Cosines for angles, not forgetting my inverse cosine, and I got it right there. Please don't forget your degree symbol. So the question is, what about B? Well, you could go through the whole thing again, do cosine of B equals blah, 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 blah. Or you could simply use the angle sum theorem. 180 degrees minus the given 105 minus the found 44.788 is this value. So you could easily, if you want, I have no problem. Once you have shown me that you know how to use a law of cosines, I don't need you to show it to me twice. So please feel free to use geometry. I know that when we did right angle, there were some times where maybe we said, make sure you're using trig, but that's because, I wanted to make sure you could do sine and cosine, not just sine. Or I wanted to make sure you could do tangent of 2 ratios, not just 1. But, you're showing me here that you know how to use the law of cosines for sides. You're showing me here that you know how to do it with angles. Okay, to look at that on Desmos, again, Desmos is just, everything's on the screen. So all you have to do is just type in 180 minus 105. I just literally Control-C, Control-V that in, and you can see I got the exact same answer that I got using a calculator.